Good morning, friends. So this is the IUPAC third video for IUPAC names. So here nomenclature of polycyclic compound. Alicyclic compounds, aliphatic compounds. I mean, some have cyclic structure. They don't have bond resonance structure. So some are side chains there. So I will tell you. You can understand now. So what happens? Side chain ring is there. Side chain. If side chain, both ring and chain structure will be both are attached. If side chain is very longer, then parent you have to take it as a parent chain. If ring is greater than side chain, if ring is greater than means not size it is. So in ring, if number of carbons are more, then we have to take it as a parent chain. Then we have to, if ring number carbons are more than side chain, we have to take ring as a parent chain. If ring and side chain are both number of carbons are same, then we have to take ring is also a parent chain. So if functional group are unsaturation present in side chain or cyclic ring, then what happens? If unsaturation or functional group present on ring side, on side chain, so then we have to take it as a parent chain. If it is not present on ring chain, it is only present on cyclic ring, then we have to take it as a parent chain. Okay. So now we are going to discuss about these examples are there. This is a science ring 1, 2, 3, 4, 5. We have to take longer one. This is 1, 2, 3, 5 carbons. This is only this have to take parent chain. Here this also total it has parent chain. So 1, 2, 3. If the one is there, if this is a functional group, unsaturation present in side chain. Whatever it is, 5 member ring, it is only 3 carbons. We don't care it is. So we have to take the more number of side chain or unsaturation present. You have to take this as a parent chain. Okay. Here listen what happens here. So this is a unsaturation. This is a substituent. Substituent is unsaturation. We have to preference first. 1, 2, 3, 4, 5, 6. This is the order. So 3, 6 dichlorohexene it is. So this is one. This is a ring chain is more than this one. No, this is a functional substituent group present in ring chain. You have to take this one only. 1, 2, 3, 4. You have to take remember. Next it one. Actually, this is a 3 carbon compound. This is 5 carbon compound. But here a substituent is there. We have to take this chain as a parent chain. Okay, 1, 2, 3. Why? Because here functional group is there. Here coming to this form, how can you write it? This is a ring form. So unsaturation is present. In this, we don't have 4 carbons is there, but we don't have. Here unsaturation is there. So we have to take from this here. 1, 2, 3. First we have to complete the unsaturation carbons. Then only we go for free carbons. So 1 and next to carbon attached is this one, double bond. 1, 2, 3. We go through next one. So coming to this point, what happened here? This is a carbaldehyde. This is cyclopentane. Carbaldehyde. Cyclopentane carbaldehyde. It is cyclohexane. It is not a pentane. It is cyclohexane carbaldehyde. It is cyclopentane carbonitrile. It is cyclopentane. Here, what happens here? This is cyclopentane carbonitrile. It is cyclopentane carbonitrile. Coming to this point, here we have to start from unsaturation position. So this is fluoro, this is fluoro. These are substituent group we had done there. Substituent group, these are unsaturation. Unsaturation is more preference. So if you take from this here, is it okay? Or if you take from this here, which is correct? You have to listen. Here both chlorine and unsaturation is started. So we have to start from here to here. 4, 5, 6. This is the correct option. Okay guys, next what happened here? Listen carefully. So here, if 2 rings are present, how can you remember it? How can you identify it? If 2 rings are present. So here, this is one ring, this is one ring. But these rings are same. So this is one ring also, this is a cyclopentane also, this is also cyclopentane. 1, 1, bis, both are there. Bis cyclopentyl or cyclopentane, whatever it may be, you can write like this. Both 1, 1 cyclopentane. Bis cyclopentane. Two cyclopentanes are there. So coming to this point, this is cyclopentane, this is also cyclopentane. Okay, very good. So what happens here? 1, 3 dicyclo. Here we can write also like this. Bis, not bis. Okay, 1, 3, 1 dicyclopentyl. This is how many carbons here in center? Commonly propane is there. Here coming to this one, this is butane, this is propyl, this is propane. So what happens here? 1, 2, 3 position we have to take side chain as a parent chain. So at first position cyclobutyl is present, 1 cyclobutyl is attached. At third position 3 cyclopropane is there. Okay, 3 cyclopropyl. Total how many are there? Propane is there. So this is the answer for this one. So how can you identify this one? So 1 cyclopropyl, 1 cyclopentane over. This is the naming. How to name it is. Okay, you are getting my point. Okay, next one. Here listen. Here what happened here? So compounds by if rings are there, 2 or more rings are there. We know that how can we identify this. But if they are fused, how can you find out? If fused means so they are attached by one another. How can they will common give? How if you will give common names to them? So now we are going to discuss about them. So bicyclo compounds are 2 types. Number 1 is fused ring. Second one is spiro. Number 1 is fused ring. Second one is spiro. So here infused rings, share more than 2 carbon atoms. So they will share more than 2 carbon atoms. Prefix bicyclo. Prefix we have to use bicyclo as a compound, bicyclo as a naming. So numbering always start from larger to small, big ring to small ring. Here we have to name like this one. If bicyclo is there, if larger number, then less number, it is very less number. So we have to use which number carbon is there, alkane. If it is butane, okay, butane. Like this is a descending order. For this one, here more than 2 carbon atoms share. Here only 1 carbon will be share. Next, spiro compounds. What happens here? Spiro compounds are they share less than 1 carbon. They share a 1 carbon as between rings. They share only 1 carbon rings. Here prefix is spiro. Number start from small to big. Here I am telling you spiro, small to big. Here bicyclo, big to small. You have to remember. This is a trick, a small trick for you. So spiro. It is, we have 1 carbon bridge is there, 1 carbon compound. So we have to side rings. So in rings, how many carbons are there? We have to write here. Alkane is a descending order. Why? Because small to big it is. So ascending order. Small to big means increasing number of carbons. This is the way. You are getting my point. Okay, next one. Here, suppose this is a compound. This is a head atom. This is a head atom. This is also a head atom. Here 1 carbon is bridge. These 2 carbons are bridge. These 2 carbons are bridge. So we now we are going to name how to name these compounds, bicyclo and spiro compounds. I will show you now. Get it? Here examples are there. What happens here? This is compound. Is it bicyclic or spiro? You tell me. Is it bicyclo or spiro? So they are sharing only 1 carbon. If 1 carbon is there, this is called spiro. But here 2 rings are sharing what? 2 rings are sharing 2 carbons. 2 carbons means it's a bicyclo compound. So how can you write one? How can you number it? First one 1. Big to small, small to big. Bicyclo is big to small. 1, 2, 3, 4, 5, 6, 7, 8, 9. You are getting my point. Here what happens? Bicyclo, bigger ring, how many carbons? 1, 2, 3, 4. 4 are there. In smaller ring, 3 carbons. In bridge, 2 carbons. How many total? No name. You have to write like this. Here, this is bicyclo or spiro? Bicyclo. 2 carbons are there. 1, 2, 3, 4, 5, 6. How can I write? Bicyclo bicyclo, 1 2 3, 3 carbons here, 1 carbon. Okay, commonly are 2 carbons are there. Bicyclohexane. You are getting my point. Okay, next one, this one, what happens? This is a spiro. Spiro we always take from small to big. Here what? 1. Okay, 1. Take from here 1 2. Okay, 3 4 5 6 7. Like this you have to number it. Next one, coming to this form, what happens here? This is a bigger ring. Is it spiro or spiro or bicyclo? Spiro. Why? Because one carbon is common is there. Spiro, small ring to big ring. Here what happens? First, here we started from with this one number 1 2 3 4 5 6 7 8 9 10. This is the way. Next, coming to the next ring, what is there here? This is also a what? This is also a spiro. We have to start from 1 2 3 4 5 6 7 8 9. This is the spiro compound. Next one, how can you represent? This is a bicyclo compound. How can you write this one? 1 2 3 4 5 6 7 8. These are the bicyclo compound. Here started from here only. This is bicyclo compound. Even bicyclo compound is there. Here substituent is there. So by saying substituent, don't go through that way. So even is there, even substituent carbon is there. We go from our rules. What is that? This is bicyclo compound. Bicyclo compound started from larger atom to smaller atom. 1 2 3 4 5. Okay, 5 6 7 8 9. This is the order. How can you identify this? Okay, next coming to this, coming to fund. So we have so many benzene compounds are there, but they are very, we will use common names for them. So some of the benzene compounds is there, so we have to use common names for them. What are the common names we will tell. So if benzene with OH group is there, OH group is there, we have to name it as in commonly phenol. If benzene with amine group is there, NH2 group is there, it is called as aniline group. If benzene is attached with OCH3 group is there, then we have to tell it as anisole. If toluene, it is benzene is only CH3, not OCH3. If OCH3 is attached directly, then anisole. If CH3 only attached, it is called toluene. Now, if benzene is attached with COH, this is called benzoic acid. If benzene react with directly COH group. Now coming to this point, this is sulfonic acid. This is benzosulfonic acid. We call it as, that is sulfonic acid. So we call it as benzosulfonic acid. So friends, here what happens here? This is benzocarbonitrile. This is called benzocarbonitrile. You can write like this. So if benzene is there, if benzene is attached with some group is there, it is a group. So adjacent to that one. So we will start from here now. We will start from this position 1 2 3 4 like this. So this position is called ortho. This position is called meta. This position is called para. Ortho. These both are ortho positions adjacent to attached carbon. So for this attached meta positions are there. This is para, this is also para, but para position group is attached. That's why we can't call as it is para. Okay, these both are opposite, both are para. These are these side by side are meta. These are ortho positions. You have to remember. So these lines are useful in next class. Okay, next class. Okay, thank you. Okay, friends, up to here we completed half of the general organic chemistry. We will go in next video. Actually, we are teaching this what organic chemistry, general organic chemistry. Totally, first of all, on totally basis we will discuss first. Then only we go through lessons. Okay. If you got concept or if you got basics, you will get good marks in exam also. If you start a lesson, you can clearly identify the compound. Okay, thank you. We will meet next video. So please subscribe my channel and share to your friends and tell them to subscribe the videos. I will provide daily videos whatever you want. If you want any more than video, or if you want to tell any suggestion, please give a comment on the box. Okay, thank you. Bye friends, bye.